everyone, this is Sukruti Joshi from LJ Institute of Engineering and Technology, Ahmedabad. I am going to take the video lecture series on chemistry. The subject code for chemistry is 3110001. In our previous session of this particular video series, we have started our chapter number 4. Chapter number 4 involves the study of polymers, rubbers and fibers. So, till now we have seen that what is a polymer actually. After that, we have seen that what do you understand by polymerization and what is the meaning of degree of polymerization. We have seen that what is a monomer. When n number of monomers combines with each other, they form a long chain which is known as polymer. Afterwards, we have seen one by one different types of classification of polymers. For an example, based on its sources, that we can divide it into natural and synthetic source. After that, we have divided or we have classified on the basis of their own structure, like linear, like branched, like cross-linked. And last but not the least, classification based on the molecular forces which are present in it. So, till now we have an idea about how it can be classified, which are the types of polymers, how their structure can be defined, etc. Now, let's begin with the new topic, which is polymerization. So, the process with which n number of monomers combines with each other and forms a long chain is known as polymerization reaction or simply polymerization. Now, we can divide the types of polymerization into two main parts. First part is the chain polymerization, or it can also be known as addition polymerization. Okay? Another type of polymerization is the step polymerization or condensation polymerization. So we have divided the mechanism of polymerization or the process of polymerization based on its mechanism in two main types. First one is a chain. Second one is a step. So I should say that one is an addition one. We just have to add the monomers. Nothing will be removed. While second one is a condensation polymerization. Condensation polymerization means there certain small molecules are released or it can be formed during the process of polymerization. Okay? Now, let's take a look on the types of polymerization along with their mechanisms here. We will take a look at using the example in a deep study here. Okay? The first type is condensation polymerization. So what is the meaning of it? So condensation polymers are those polymers in which two like or unlike monomers join each other by the elimination of small molecules such as water, such as HCl, that is hydrochloric acid. Here the removal is being done. Okay. Now, let's take a look on the mechanism of the condensation polymerization. So students, what is the meaning of it here? A general mechanism for any kind of condensation polymerization involves a simultaneous combination of any two monomers to give diamonds. Okay, when two combines, it called as diamond. When three combines, trimers. More than two combines, it is known as polymers. So here, which in turn combine to give tetramers. As I said, if it becomes 4, it becomes tetramers, and soon and finally grow into a polymer in a stepwise manner. Okay, it's a step-by-step process. As we have seen, this is also known as step polymerization. Okay, so this can also be known as step polymerization, right? Condensation polymerization because it removes certain small molecules. When we talk about the step polymerization, because they combines in a stepwise manner. Okay, in this manner it will form a whole mechanism. So now let's take a look on the actual practical mechanism of step polymerization or condensation polymerization. Here I have given you an example of nylon 6:6. So it can also be known as polyhexamethylene adipamide. Nylon 6:6, another name is polyhexamethylene adipamide. Why is it so? So nylon 6:6, as you can see in the image, is made up of two different monomers. First monomer is hexamethylene diamine. Why it is known as hexamethylene diamine? Because it contains 6 methylene molecules, as you can see here, and 2 amine molecules. So they forms hexamethylene diamine. Another one or another monomer is adipic acid. So we can take a look at here that it contains a structure which is COOH, single bond CH2, contains 4 atoms of methylene and 4 molecules of methylene, and again COOH group. Both of this combines together, an amide bond formation occurs between the amine group of the hexamethylene diamine and the COOH group of adipic acid. Both of them forms an amide bond and the whole chain continues to forms. This whole chain continuously formed a whole long nylon 6:6 monomers polymer. That means 2 monomers combines with each other and forms the polymer. Here, as you can see, the removal of water molecule occurs, H from the hexamethylene diamine and adipic acids OH. So H and OH combines and H2O molecule is removed from it. So here, as you can see, we got an idea that how the long chain is formed. You can observe it in the whole long chain, that how the amide bond formation occurs and why nylon 6:6 is considered as one of the best polymers, one of the most durable polymers. So in the image you can see the structure of nylon 6:6 or structure of polyhexamethylene diadipamide. Okay, it's polyhexamethylene adipamide. Here, next topic that we will take is chain polymerization. Chain polymerization is also known as addition polymerization. Addition polymers generally formed by adding monomer units without loss of any compound, without loss of any molecule. And because of it, it is known as addition polymerization and not any other. In the image, I have given you certain examples in which you can see that n number of ethene monomers combines with each other to form polyethene, right? As you can see, n number of CH2 double bond CH2, which is the structure of ethene, combines with each other and forms polyethene. Similar way, we have another example of vinyl chloride and CH2 double bond CH, single bond Cl, which is the structure of vinyl chloride. So they combines with each other and forms a long chain, which is known as polyvinyl chloride. PVC is a widely used material in our routine life, and it can be formed very easily. Okay, now very important one is the difference between condensation polymerization and addition polymerization. So we will take a look on their points one by one. First is the condensation polymerization. The points that we will take is condensation. The opposite point will be of addition polymerization. So here condensation is also known as step growth. Addition is known as chain growth polymerization. Then next is it takes place in the monomers having reactive functional groups, while the addition one takes place only in the monomers having multiple bonds. They must have multiple bonds in it. Then in condensation polymerization, it takes place with the elimination of simple molecule like H2O, NH3, HCl, etc. But when we deal with the step, the addition one, it takes place without the elimination of any kind of molecule. It can be simple, it can be complex, but it will not remove any kind of molecule from it. Next is the repeat units of monomers are different. While we deal with the addition one, the repeat units and the monomers are same. We don't vary it here. Okay. Then the polymer is formed in a gradual step because it is known as step growth polymerization, right? So it is taking place in stepwise manner. Afterwards, we have another opposite, that is the reaction is fast and polymer is formed at once. It doesn't require any kind of step. It generally occurs in a single step reaction and it's very fast. It can happen in a minutes. Okay. Then when we deal with this one, in condensation polymerization, the molecular mass of polymer increases throughout the reaction. But in addition one, there is a very little change in the molecular mass throughout the reaction. This is the main thing. Okay. In condensation polymerization, the product obtained may be thermosetting or thermoplastic, while in addition polymerization, the product obtained are thermoplastic only. This is the first and foremost requirement. Afterwards, we have the examples. So the examples for condensation polymerization involves bakelite, polyester, polyamides, etc. In addition polymerization, we can take an example of polyethene, polyvinyl chloride and polystyrene. This is all for this particular session. Next one we will have in our next session. Thank you so much everyone.